This is a video showing the STM32 Nucleo board with a 7-segment display that's going to perform a BCD converter using a 4 input switch, dip switch for a BCD value. So the way the circuit's going to happen is through the flowchart, we're going to have the actual circuit for a BCD converter. We're going to initialize the GPIO-C motors, the pull-down resistors, and the output data registers for output C. So we're going to have an input value from pins PC8 through PC11 on the dip switches. It's going to take those values, it's going to logically shift them right, and it's going to mask the lower significant bits. And it's going to use that value, and then it's going to compute what's inside the table, and then it's going to output those to PC0 through PC7. And then it's just going to repeat that in case any of the values ever change. So as far as the code, we have a few initializations that happen up top, such as the reset handler, which starts off, and then we start off the internal clocks, we start off the mode registers, output data registers, the input data registers, and then the internal pull-up resistors. From there, we're going to start each value, and we're going to define them. And then we're going to get into the actual bulk of the code. The bulk of the code is going to be right here, which starts with an again loop, which is a be again loop. We're going to load in the value into R3, which is pointed by R0's location, and R0 is going to be the input data register, which is going to be the BCD input. It's going to take that value, which is now pointed or put into R3. It's going to logically shift it right 8 bits, and then it's going to AND it with the 0F value, and then store that value back in R3. From there, it's going to use the R3 value pointed by R2 and put it for the display table, which is going to pull the value from this display table, which goes from 0 to 9, and then A, B, C, D, E, and F. From there, it's going to put the value in R8, and then R8 is going to output the value for the location pointed by R1, and R1 is going to be the actual output data register, which is going to be C0 through C7 ports. And then we go to the actual binary setup. Currently, we have all the dip switches in the 0 position, which is off. Flip the first one, should get a 1. Flip the second one, and then back off 1 to show that we get a 2. Flip the first one back up, you get a 3. Flip them back down, and put the third one up to get a 4. Sorry, just a little bit janky on the switches. And then put this up for 5, back down, second one up for 6, all 3 up for 7. Put them all down, and the last one's going to be up for 8. In order to get 9, you're going to put the last one up, last one up. In order to get 10, you're going to keep 8 up, put that up, so you got B, put this one back down, get C, and D, then E, and then F. So we just went through the whole sequence of all 15 values, 0 through 9, and then A through F for the BCD input for assembly language.